So now we are almost clear with the chain rule. So today we continue with the next exercise 5.3, which is also about chain rule. Before I start 5.3, let me take some basic examples. Suppose we have x square. So what's the derivative of x square with respect to x? 2x. Now suppose I have y square. Now derivative of y square with respect to, if you do x, it is not 2x, remember. So what we do is, we imagine these are x, chain rule in short. So what is derivative of y square? That is 2y. Now by chain rule you had considered y as x. So d by dx of here y. So this is the derivative. This is by chain rule. Derivative of y square with respect to x. What is derivative of y square with respect to x? That is 2y into dy by dx, remember. You imagine y as x. So derivative of x square is 2x into derivative of y with respect to x, that is d by dx of y. So 2y dy by dx. Same way, if I take y cube for example, what is derivative of y cube with respect to x? With respect to x you are doing, remember. So again I'll imagine y as x. So this looks like x cube. What is derivative of x cube? 3x square into, by chain rule, d by dx of considered function. You had considered y as x. So I'll put y here. So what is derivative of y cube with respect to x? 3y square dy by dx. One more, suppose I want this. D by dx of, let's write sine y. Now how do we differentiate? So what we do? We don't have derivative of y directly. So I'll imagine this as x. So what's the derivative of sine x? You know cos x. So cos y into differentiation of y with respect to x. So dy by dx. So what's the derivative of sine y with respect to x? Cos y into dy by dx. Same way, suppose I want d by dx of, let's write log y, sorry. So what I'll do, imagine y as x. So what's the derivative of log x? 1 upon x. So 1 upon y into, by chain rule, d by dx of y, that is 1 dy by dx. So what's the derivative of log y? 1 upon y dy by dx with respect to x. With this clarity, I'll go to first question. Remember, this is very basic. I'll go to first question there. Everywhere you are asked to find dy by dx. This is the question. Now, in earlier exercises, you had everywhere y equals to function of x. You had an expression about x. Expression for x, remember. Expression for x. But now, here in these exercises, we have mixed expression. If you especially see question number 1 to question number 9, these are mixed expressions, mixed equations. Mixed equations means what? Equations about x and y. So such functions are called implicit functions. Implicit functions. Implicit functions. Okay. So let's see how to do the derivative of implicit functions. Implicit means mixed equations about variables. You see question number 1 here, first question. 2x plus 3y equals to sine x. This is a mixed equation, remember, about x and y. Earlier you had such questions, y equals to like this, sine x minus, for example, 2x plus, for example, 4. You see here, y equals to purely in form of x. This is sometimes called explicit function. explicit function. Explicit and implicit. Explicit means purely in form of x. You recall all earlier exercises questions. Here you have mixed equations. So we'll not make the y as a subject of expression. What I'll do, we differentiate it directly. So I'll write one line here, differentiating with respect to x. Right? That's the standard way of doing this. Now tell me, what is the derivative of 2x? You know 2. 2 as it is, derivative of x with respect to x is 1. 3 being constant as it is, what's the derivative of y with respect to x? dy by dx. Derivative of y with respect to x. Derivative means you are applying this operator, remember, d by dx. Of which function? Y. So dy by dx. What is the derivative of sine x? That's a cos x. Right? Now you make the cos x as a subject, dy by dx as a subject of the expression. So what is dy by dx? That is cos x minus 2 by 3. This is your answer. dy by dx equals to cos x minus 2 by 3. Just you make the dy by dx as a subject of the expression. Fine. Now in the next question, let's see the question number 2. So second question here, 2x plus 3y equals to sine y. What is the question? Question is same everywhere, get the dy by dx. So what I'll do, I'll differentiate with respect to x. Differentiating with respect to x. Differentiating with respect to x. What is the derivative of 2x? 2. 2 as it is, what's the derivative of x with respect to x? It's 1. So 2 into 1, 2. 3 being constant as it is, what's the derivative of y with respect to x? dy by dx. Now as I explained, we don't have derivative of sine y. It's not there. Remember in that standard lit. So I'll imagine these are the x. What's the derivative of sine y? Cos y into, by chain rule, d by dx of considered x. What you had considered as x, y. So derivative of y. This is chain rule, remember. So now you are through. Differentiation is over. Just to get the dy by dx common from this 2. So 2 equals to, I'll take dy by dx common here. What will get here? Cos y minus 3. And therefore, what is dy by dx? dy by dx equals to 2 upon cos y minus 3. This is your answer. Next, question number 3. I'll go to third question. ax plus by squared and cosine y. What is the question? Question is get the dy by dx everywhere. This is the question. Get the dy by dx. So what I'll do? Differentiating with respect to x. On both the sides you are differentiating, remember. A constant, b constant. So a as it is, what's the derivative of x with respect to x1? B being constant as it is. Now these are already explained just now. What we do? We imagine y as x. So 2y into now derivative of y with respect to x, which is dy by dx. I hope this is clear to you. Remember, what's the derivative of y square? 2y into dy by dx. What's the derivative of y square? 2y into dy by dx. Now come to this chain rule here. You imagine this as x. What's the derivative of cos x? Minus sine y into, by chain rule, derivative of consider function, that is derivative of y with respect to x. In short, whenever you have y, you should write at the end dy by dx. Okay, so differentiation is over here. Now we collect all the terms having dy by dx. So I'll take the dy by dx common here. So this is 2by. You take this one on the right side, plus sine y equals to, I'll take this one a over there, so minus a. What I did? Taking dy by dx common from this 2. So 2by plus sine y minus a. So dy by dx equals to minus a upon 2by plus sine y. This is your dy by dx. Next question. The next question, question number 4. Let me go to fourth question. The fourth question, you have xy plus y square equals to 10x plus y. This is again just I'm reminding you, for you it's not important. This is implicit function, mixed equation about variables. Remember, all variables are there in a single equation. So we write one line, differentiating with respect to x. Remember, here you have product of two functions, product rule. This is just y square, that you know. So here I am going to use the product rule. X as it is, differentiation of y, dy by dx, derivative of y with respect to x. You are applying d by dx factor to y, remember, plus now y as it is, differentiation of x with respect to x, you know it is 1. These two terms because of x into y, product rule, remember. It's not like this, remember, differentiation of x into y is not just like here x and here dy by dx. Right? This is wrong, remember. This is wrong. You need to use the chain rule like this, remember. Use the chain rule like this. Okay. Now we are at this place. Plus, what's the derivative of y square? Imagine this as x. So this looks like x square. So this is 2y into differentiation of y with respect to x. Chain rule here. Now you know very well. Equals to, now we are here. What's the derivative of 10x sec square x plus what's the derivative of y with respect to x? Dy by dx. Derivative of y with respect to x, that is you are applying d by dx to y, that is dy by dx. Now how many terms are having dy by dx? 1, 2 and 3. So I'll take all these terms on one side. So dy by dx, here you have x, here you have 2y. I'll take this one on the left side. So minus x squared x, and this y I'm taking on the other side. So minus y. This is simple algebra, remember. Differentiation is over here. Okay, so what is dy by dx? That is here minus y upon x plus 2y minus x squared x. This is your answer. In the fifth question also you have product rule. I'll go to sixth. There also we have product rule. All three are similar. I'm going for sixth question. You can try fifth yourself. Okay. 1, 2, 3, 4, 5 terms. Here your product, remember. Here your product. So differentiation. Differentiating with respect to x. Chalo, come to first one. What's the derivative of x cube? 3x square. Here product rule. X square as it is. What's the derivative of y with respect to x? Dy by dx. Plus, now y as it is. What's the derivative of x square? You know very well, 2x. These two terms are because of this, remember. Don't forget, here you have product. Plus, we are over here now. X as it is. You know derivative of y square. Now we did 4, 5 times. You imagine y as x. So this looks like x square. So 2x means 2y into dy by dx, remember, product rule, into dy by dx plus now here y square as it is. What's the derivative of x with respect to x? 1. So we have this. Okay. These two terms are because of this. Now we are here. Plus y cube. That you know very well. What's the derivative of y cube? Imagine y as x. So 3y squared into dy by dx. By chain rule, remember. Equals to 81 being constant, derivative is 0. Derivative of any constant, you know that it is 0. Okay. So differentiation is over. Now we collect all the terms having dy by dx. Together, this and this. So I'm taking dy by dx common from all this. So this is x square. What about this? 2xy. Here 2xy plus 3y square, and remaining terms I'm taking on the right hand side, remember. So this one, this is free from dy by dx. This one also free from dy by dx, and this one also free from dy by dx. So I'll take 3 terms on the other side. So minus 3x square minus 2xy and minus y square. I hope this is clear to you. So therefore, what is dy by dx? Equals to, you can just keep minus common. So here 3x square plus 2xy plus y square upon this x square plus 2xy plus 3y square. This is your answer, remember. So this last step is just a simple algebra, remember. This is the only important portion. You must realize these two terms because of the single term by product rule. Okay. Next question. Question number 7. What's the question? Get the dy by dx. The question is same everywhere. Find the dy by dx. So what we do? We differentiate it with respect to x. I'll write differentiating with respect to x. Okay. Now, how will differentiate this? By chain rule. Do we have derivative of sine square y? No. So I'll imagine this as x. This one. So what is this? This is x square. What's the derivative of x square? 2x. So 2 sine y. Now derivative of sine y. What is the derivative of sine y? Cosine y into dy by dx by chain rule. Remember, 2 times you have used chain rule here. Whenever you have y, always at the end you need to put the dy by dx. Keep this much in your mind. I repeat this. Imagine this sine y as x. So this is x square. What's the derivative of x square? 2x. Now it's done for sine y. What's the derivative of sine y? Cos y, and derivative of y with respect to x dy by dx. Plus, now we are here. So we imagine again this bracket as x. So what's the derivative of cos y? That is minus sine of xy. Which one you had considered as x? xy. So there we have the product rule. So I'll write here d by dx of x into y. That I'll do in the next step. And what's the derivative of constant k? 0. K constant, so derivative is 0 here, remember. K being constant, derivative is 0. I repeat this. Here, this is clear. You imagine this as x. You don't have derivative of cos of xy. So this is x. What's the derivative of cos? Minus sine into d by dx of xy. And what is the derivative of constant? 0. Now you know this is a standard formula. This is sine 2y into dy by dx minus sine of xy. Here you have product of two functions. So you need to use product rule, remember. X as it is, what's the derivative of y? Dy by dx plus y as it is, what's the derivative of x with respect to x? It is 1, remember. So differentiation is over. What is the important step here? These two terms because of this product rule, remember. Now simple algebra. You open the bracket and you collect all the terms having dy by dx in one bracket. Minus x into sine of xy into dy by dx minus y into sine of xy equals to 0. I have just opened the bracket. These two terms are having dy by dx. So I'll take dy by dx common. This is sine 2y minus x into sine of xy. This I'll take on the other side, y into sine of xy. And therefore dy by dx equals to finally this upon this. This is your answer. Okay. Next question. Question number 8. There we have sine square x plus cos square y equals to 1. Okay, so differentiating with respect to x. What's the question? Get the dy by dx. This you know very well now. What's the derivative of sine square x? 2 sine x cos x. Remember. This is x. So 2, this looks like x square. So 2x into derivative of sine, which is cos. Remember here you had y. So again you need to do dy by dx. Here that's not necessary, remember, because this is already x. Now look at it, next one. Again you imagine this as x. So 2 cos y. This is like x square. What's the derivative of x square? 2x into, now derivative of cos y. What's the derivative of cos y? Minus sin y. Now here y is there, so into dy by dx equals to, what's the derivative of 1 being constant? 0. I repeat this. You imagine this as x. So this is x square. So 2x derivative of cos, which is minus sin y, and then in turn derivative of y, which is dy by dx. Okay, so this you know, this is sine 2x, this is sine 2y into dy by dx. So therefore what is dy by dx? This I'll take on the other side, minus sine 2x upon sine 2y. This is dy by dx. Sorry, here there is a little correction. Because of this minus, here we'll get minus. So if I take on the, this is minus, sorry, that was my mistake. And here if I take this on the other side, this is just plus, remember. So plus sine 2x upon 2y, that is your answer. Now next lot, that is question number 9-2 till last question. It's about inverse trigo functions. So here beginning is your chapter number 2. At the end we do the differentiation, remember. Question number 9, let me go to that. Y equals to sine inverse 2x upon 1 plus x square. Now usually in inverse trigo questions of differentiation, normally inside the bracket always you will find the standard formula. Now if you remember, this is nothing but the 2t upon 1 plus t square, 11 standard. So we put substitution, put x equals to tan theta substitution. So if I put there, you have y equals to sine inverse 2 tan theta upon 1 plus tan square. And you know very well this is nothing but the sine 2 theta inside the bracket. Sine 2 theta. This is the formula of sine 2 theta. 2t upon 1 plus t square, double angle formula if you remember. You must recall these three formulas. One is sine 2 theta equals to 2 tan theta upon 1 plus t square. The second one, if you remember, cos 2 theta equals to 1 minus tan square theta upon 1 plus tan square. This is also very well known formula. And tan 2 theta is just the ratio of these two, that is 2 tan theta upon, if I take a ratio, plus term will get cancelled, 1 minus tan square theta. You know, these are very important formulas from trigo. 2t upon 1 plus t square, 1 minus t square upon 1 plus t square, and similarly this. So I have used this formula here, remember. Okay, now this 2 will get cancelled, you know, from inverse trigo. So you are getting y equals to 2 theta. What is theta from this? You know, theta from this is tan inverse x. So this is simplification. Such questions you did in chapter number 2. If you have this, prove this. Such things you did. This is chapter number 2, remember. It has nothing to do with differentiation. Chapter number 2. Now differentiation is just one line. Dy by dx equals to 2 being constant as it is. What's the derivative of tan inverse x? 1 upon 1 plus x square. So this is your answer. Differentiation is just last line, remember. This is chapter number 2. Okay. Question number 10 now. Let's go to 10th question. Y equals to, you have tan inverse 3x minus x cube upon 1 minus 3x squared. You must have realized 33 upon 32. That's a formula for tan 3 theta. So immediately what is your substitution? Put x equals to tan theta. So what you will get here? Y equals to tan inverse. Why I have taken this substitution, that you must realize, remember. Okay, one more thing. Here you are given condition on x also. This is also important condition. Condition is from minus 1 by root 3 to plus 1 by root 3. This is given to us. We'll use this. You will realize. So this is 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Now what is this? This is tan 3 theta. So y equals to tan inverse of tan 3 theta. This is the formula of tan 3 theta. Now before, you know from chapter number 2, before you cancel these two, you need to assure that 3 theta, this angle should be in the domain of tan function. What's the domain of tan function? You know, minus pi by 2 to pi by 2, this portion, if you remember. This is the domain of tan function, chapter number 2. So that much you should assure. Normally it is always, but in MCQ sometimes it may not be. Okay, so we go back to theta. What was x? Theta comes from x, remember. So here, for example, if I put x equals to 1 by root 3, then here as I'll write theta. If I put 1 by root 3, so for what value of the theta this become 1 by root 3? That is pi by 6. So this has to be minus pi by 6. This condition comes from this substitution, remember, and from x. Okay, you need 3 theta. So multiplying this by 3 theta. 3 only. So if I multiply this inequality by 3, I'll get this. Minus pi by 2 less than 3 theta less than pi by 2. So now you see here this angle is in the domain of tan function, minus pi by 2 to pi by 2. So now you have shown that this angle is in the appropriate domain, and therefore you can cancel this 2, remember. And therefore finally you are getting y equals to here 3 theta. And therefore y equals to, what is theta? That is tan inverse x. X is tan theta. So what is theta? Tan inverse x. This is chapter number 2, differentiation, just one line, 3 being constant as it is. What's the derivative of tan inverse x? 1 upon 1 plus x square. Okay. Next question. Question number 11. Y equals to cos inverse 1 minus x square upon 1 plus x square. What's the condition on x? 0 to 1. Okay, so again this is clear to you. What should be the substitution? Put x equals to 1 minus t square upon 1 plus t square. So I'll put x equals to tan theta. So what is y here? Y equals to cos inverse 1 minus tan square upon 1 plus tan square. Why we have chosen this substitution? Because you know this formula from 11th standard. What is cos 2 theta? 1 minus tan square upon 1 plus tan square. Cos is already there outside, remember. So therefore y equals to cos inverse cos 2 theta. Double angle formula, remember. If you want, you can write just formula here. Formula for cos 2 theta. Fine. Now, what is the important step? You need to show that 2 theta should be in the domain of this function. I repeat, 2 theta should be in the domain of this function. cos function. Can you recall what's the domain of cos function? 0 to pi, if you remember. This is the domain of cos function. So I'll come back to theta. How do I write the range on theta? From where to where? Based on x. Theta comes from x, remember. So first I'll put 0, this limit. If I put 0, then tan 0 is 0, so this is 0. I'll put 1 here, so you know that this is pi by 4. I need 2 theta, multiplying with 2. So 0 to pi by 2, that is this quadrant. So it is in the domain, either first or second, it is in the first quadrant. So now you can cancel this 2, remember. So y equals to, we have 2 theta. What is theta? What is theta from this? If you want, you can write here only. What is theta from this? Tan inverse x. So 2 times tan inverse x. This is nothing but, remember, this is chapter number 2. You have not done anything about differentiation so far. Inverse trigo functions. This can be asked in inverse trigo chapter, that prove that this equals to this, and you had such questions. Okay, now differentiation, that is just one line. Dy by dx equals to 2 being constant as it is. What's the derivative of tan inverse x? 1 upon 1 plus x squared. So this is your dy by dx, remember. Okay, so next, now question number 12. Question number 12. What is that question? Y equals to sine inverse 1 minus x squared upon 1 plus x squared. Okay, so how will do this? Okay, let me write range on x. Range on x is this. You know that this is the formula for, as you did in the previous question, cos function. So let us take the substitution. Then we'll reduce. I'll tell you how to do later on. Okay, so put x equals to tan theta substitution. What is theta from this? Tan inverse x. So what we'll get here? Y equals to sine inverse 1 minus tan squared upon 1 plus tan squared cos 2 theta. Okay, I've dropped one step. Remember, you should write this step here. Cos 2 theta, I've used this formula, that is 1 minus t squared upon 1 plus t squared. I've used this formula, remember. Okay, fine. Now you cannot cancel this 2. This should be reduced in what? Sine, or this should be reduced in cos inverse. Now whichever way you want to do. If you remember, you can use this formula. Sine inverse x plus cos inverse x, if you recall, pi by 2. So what I'll do, this you can keep as x in your mind. So I can write sine inverse x equals to this much. So I'm using that. So sine inverse x equals to pi by 2 minus cos inverse cos 2 theta. What is sine inverse? Pi by 2 minus this, but instead of x you have this bracket. Now this you can cancel, but before you cancel, as I explained, this 2 theta should fall in the domain of cos function. What's the domain of cos function? 0 to pi, you know. Now don't ignore this. This is very important portion here. In the subjective exam, if you are not going to show, you will lose the marks, remember. Sometimes your answer may be wrong also. It's very simple. So we go back to theta. How do we write condition on theta? Based on this, put 0 here. Tan theta equals to 0. So theta has to be 0. Put 1 here. Tan theta equals to 1. So theta has to be pi by 4. I need 2 theta. So I'm multiplying with 2. So your angle 2 theta is in now domain of cos function 0 to pi. Here it is 0 to pi by 2. Fine, either first or second quadrant. So now we are cancelling this 2. Pi by 2 minus 2 theta. What was theta? Theta was, tan inverse x. Again I am emphasizing this is nothing but chapter number 2, remember. Inverse trigo function. Chapter number 2. Differentiation will now come into the power. So differentiation, just one line. What's the derivative of pi by 2? Being constant, 0. 2 as it is. What's the derivative of tan inverse x? 1 upon 1 plus x square. So it is minus 2 upon 1 plus x square. Okay. Now here at this place, over here you could have done like this also. It's up to you. From this place you can do like this also, or choice is yours, whichever way you want to do. You can do y equals to sine inverse. Instead of cos you can write sine pi by 2 minus 2 theta. That way also you can do. What I did, instead of cos alpha I wrote sine pi by 2 minus alpha. You can cancel this 2. You can show that this is in the domain, not a big task. So you are getting pi by 2 minus 2 theta. See, you are getting this step. The choice is yours, whichever way you want to do, remember. Okay, fine. Next question number 13. Y equals to cos inverse 2x upon 1 plus x squared. So you must have realized here this is a formula of sine 2 theta. So put x equals to tan theta. So what is theta from this? Tan inverse x. You can continue. So here just I'll show you in short. You will get the cos inverse sine 2 theta. Then either you convert, now like previous question, either you convert this one in sine inverse or this one is in cos, and show that this is in appropriate domain. What is the range on theta? So let me show you here. Put here minus 1 or 1. If I put 1, tan theta equals to 1. So theta has to be pi by 4. If I put minus 1, for what value of the tan theta it becomes minus 1, so minus pi by 4. And then just multiply with 2. So minus pi by 2 less than 2 theta less than pi by 2. Right? And then just finished it. Okay. Question number 14 now. Y equals to sine inverse 2x into root of 1 minus x squared. Range is from minus 1 by root 2 to 1 by root 2. Now if you recall, this is like 2 sine theta cos theta, remember. So what we'll do? We put x equals to sine theta substitution. You can put cos theta also. Then it becomes 2 cos theta sine theta. Choice is yours. What is theta? Sine inverse x. Okay. We place there. So this will be sine inverse 2 sine theta into root of 1 minus sine square. So this will be y equals to sine inverse. This is 2 sine theta. Actually this is inside the square root of cos squared. So it becomes modulus cos theta, but I am writing cos theta. Here q, that you will realize this is like modulus of cos theta, which become cos theta. Why you will realize in just a minute. Now this is sine 2 theta. So sine inverse sine 2 theta. Okay. Now can we cancel these two? Answer is yes. Only when 2 theta is in the domain of this. So go back to theta. What's the condition on theta? Come to this. Now you must have realized how I did in so many questions. Put 1 by root 2 here. For what value of the theta sine theta becomes 1 by root 2? You know pi by 4. Put minus 1 by root 2 here. So minus pi by 4. You want 2 theta. So multiplying with 2, remember. If I multiply with 2, minus pi by 2 to pi by 2. Which two quadrants? First and fourth. This one. First and fourth quadrant. This portion. Minus pi by 2 is here. Pi by 2 is here. All these things you know. And this is a domain of sine function if you remember second chapter. So this will get cancelled. So y equals to 2 theta. But what was theta? Theta was sine inverse x. And now finally the differentiation. So this is chapter number 2. dy by dx equals to 2 upon root of, derivative of sine inverse x. 1 upon root of 1 minus x squared. So this is your answer. Now here I forgot to mention this, why I wrote this, because in the first and fourth quadrant, you know that the cos is positive. So modulus cos become cos. In case if I change the condition on x, sometimes it may be minus also, remember. So you cannot ignore this. Root of x square, you cannot write always x. It's a modulus x, remember. That I've used here indirectly. Okay. Last question number 15 here. If you remember, this looks known expression. You had, if you recall, 3 formulas for cos function. 2 cos square minus 1, 1 minus 2 sine square, and cos square minus sine square. So before I do that substitution, sec inverse you can reduce in cos inverse if you remember, reciprocal of the angle. If you recall, sec inverse x you can write cos inverse 1 upon x, reciprocal of the angle. Okay. Now it's clear to you this is a formula for cos 2 theta. So I'll put x equals to cos theta. So what is theta from this? You know cos inverse x. So therefore y equals to cos inverse, what is this? 2 cos square theta minus 1. Y equals to, therefore, cos inverse, this is nothing but the cos 2 theta. I'll just remind you, you had 3 formulas for cos 2 theta. 1 minus 2 sine square theta, 2 cos square theta minus 1, and one more if you remember, cos square theta minus sine square theta, 11th standard trigo. I've used this formula here, 2 cos square theta minus 1. Okay. Now can we cancel these two? Answer is yes, only when 2 theta is in the domain of this function, cos function. So go back to theta. Let's come to theta. Put 0 here. Cos theta equals to 0. So what you will get? You'll get the pi by 2. Put 1 by 2 here. So cos theta equals to 1 by 2. So what will get here? Pi by 4. So pi by 4 to pi by 2. Smaller values should be written first. Multiplying with, I need 2 theta, remember. So multiplying with 2. So pi by 2 less than 2 theta less than pi. Which quadrant? Second quadrant. Pi by 2 to pi. What's the domain of cos function? First or second, remember. So this is in the domain. You can cancel these two. So y equals to 2 theta. What was theta? Theta was cos inverse x. So 2 into cos inverse x. Chapter number 2 so far. Differentiation, now just one line. 2 being constant as it is. What's the derivative of cos inverse x? Minus 1 upon 1 minus x squared. So this is minus 2 upon root of 1 minus x squared. This is your final answer.